Okay, I think we can start. Today I want to present my work trying to enable Virtio on Xen. So it's not Xen n.0, but the Virtio with Xen n.0, n being larger than 2, because I'm aware of at least 2 previous or current approaches, and I'm sure there are many more, so I guess n should be rather 5 or something like that. I don't know. So what I'm showing you today. So quick look at the agenda. What is Virtio? A brief introduction how Virtio is working. And then why do we want to have Virtio support in Xen? What has been done previously in this regard? What is different with my approach? How does my approach work? What is the current state of my work, and what needs to be done and discussed? Okay, what is Virtio? Virtio is a framework for PV devices, for paravirtualized devices. The main user and is KVM, and Virtio was introduced for KVM. So the Linux kernel contains a lot of support for Virtio devices. qemu does as well, and there are lots of operating systems supporting Virtio and several hypervisors as well. So a Virtio device is presented to the guest via PCI, which is on standard hardware, or x86, for example. So Virtio device is there normally a PCI device. It can be presented only via MMIO, which is basically a subset of the PCI spec. So basically the same interface, but without the PCI enumeration and detection mechanism. MMIO-based Virtio is mostly used in embedded systems. So that the user, so the guest, has to know where to look for which device. This is, for example, specified by a device tree or by a fixed constant or whatever. And for 390 machines, there's the possibility to use CCW, so the standard I/O mechanism on 390. The main I/O activity is controlled via ring pages, similar to Xen PD devices. So there's a ring page which contains the requests and where the responses for an I/O are sent back to the guest. The main difference between Xen PV devices and Virtio is that those ring pages are well-defined, have a well-defined format, or there are some well-defined formats for ring pages. So all devices, all Virtio devices share the same basic Virtio architecture. So this is not that block devices are using completely different ring page compared to, for example, XenStore, like it's the case in Xen. The backends for Virtio devices can live, in KVM case, in qemu, in the host kernel, which is then called vhost, a vhost device. Or it can be some other user daemon, which would be vhost user case. But in all cases, for x86 at least, qemu is responsible for presenting the PCI device to the guest and for starting and stopping the devices for that reason. When the device has been established and the connection between front-end and back-end is there, then for vhost, for example, everything is running without help of qemu then. So, of course, the next question, why would we want something like that in Xen? We have our PD devices, everything seems to be fine, but there are some drawbacks from only supporting the Xen PD devices. For example, there need to be, of course, a Xen PD front-end driver in the guest to be able to use those devices. And there are lots more of operating systems supporting Virtio than Xen PD guests, Xen PD devices. So this is one reason to be able to support more operating systems. There are many more device types available as Virtio devices compared to the Xen PD device types. For example, there's the VSOC, or there are some special Virtio crypt devices and more SCSI support, USB support, and things like that. So this is all much more mature and widespread than only the Xen PD device types. And of course, by supporting Virtio, it would be possible to concentrate on the main PD devices and PD device types in Xen, like block and network, because I guess with Virtio, at least in the beginning, the performance will be less than with Xen PD devices, but for more unusual devices, Virtio would absolutely be okay. So I don't think there would be a further need for supporting PD SCSI, for example, in Xen or in DOM0. And what I didn't add here, especially in the automotive area, when a customer is looking for a virtualization possibility, they often require Virtio to be available because they want to use their special purpose guest, which only is capable to speak Virtio. So what has done before? So the first support of Virtio in Xen was done by Google Summer of Code project in 2011. As far as I know, Wei was the main contributor here. At least he authored some of the patches I found. The patches were mostly for configuring the guests, because today it is even possible to use a standard Xen and use Virtio in an HVM guest, if you are clever enough to find the config runes to give as additional parameters to the qemu process with the device model. There are some further tweaks which need to be done, but I'll come to that later. Wei did some patches as well to support PD guests, but this was possible only via some further guest kernel and qemu patches, which contradicted common kernel, for example, for PD and HVM guests, because their Virtio needed to be patched to translate the PFNs to machine frame numbers. Currently, there's a small patch series floating around, which would be the N-1 version. Oh, there's a typo there. 1N should be gone. It is for configuring Virtio block in ARM guests. Again, it's an approach only to add the config capability to the Xen tools without addressing the common problems of all previous attempts. Virtio and Xen, all previous attempts neglected the Xen security model, so there's no driver domain support. The backends need the capability to map all guest memory, so it's like the emulated devices of an HVM guest. qemu needs to map arbitrary guest addresses, so there's no ground support at all. So what is different now with my approach? My idea was to add full ground support to Virtio. So, but not as mandatory under Xen, but to be able, so if front end and back end side are capable to use grants, they can use grants. If one side isn't capable, they won't use grants. Which is important, for example, for the embedded case, which I mentioned already, because if there's a special purpose OS of an automotive customer, basically they won't have the ground support built in initially, in my opinion. With my approach, driver domains are easily possible. So, okay, Julia, there's with a multiple IO rack server, yes, but the problem is driver domains are in theory possible via IO-MMUs as well, for example. But that's hard to establish. So IO-MMUs are a little bit difficult because Xen and qemu and so on have to agree on it. And on the other side, driver domains with a current normal interface are possible only if the driver domain can map all the guest memory, and this is not very nice.
Yes, that's correct. The thing you need to think also is with the ground table side support, you need modification in the front ends. And
right.
Some of the driver, some of the OS, you can't go to them and saying, oh, if you want to put on them, then you need to modify it. It's kind of like the idea of Zen on ARM where there is no modification needed like for DOM0LS to put on Zen.
Right. So this is the reason I was really serious about the negotiation. If the negotiation is not enabling grants, then Virtio is still possible, but of course with a normal background. So you need to be able to map all the guest memory from the backend. And without grants, PV guests on x86 can't be supported. So my general approach was to modify only the basic Virtio framework, not to do any changes in the specific front ends and back ends, because this would be hilarious. So this would be much too much to change. I only want to touch the framework, so the central stuff. And I started from the bottom up, basically. So I haven't done anything regarding device configuration. And there's a strong need to discuss this later. And I would really suggest to have maybe a design session today or tomorrow in this regard to discuss how to do the configuration, because the current approaches or the previous approaches were always targeting at, for example, the disk or the network configuration options. But what do we do with SCSI, with USB, with vSOC, with grid, and so on? Would it probably make more sense to have common Virtio configuration layer or syntax. So if there's some interest, I'd be happy to register another design session. So how does my approach work? On the interface between front-end and back-end, all references to guest memory are DMA addresses per design. So on x86, this happened to be PFNs or physical addresses, physical guest addresses, but in fact, those are DMA addresses. And what is nice, the Virtio framework allows for per-device DMA operations in the guest. So 1 bit in the Virtio feature map allows for switching to specific DMA ops on the front-end side. But this is done in the Virtio framework, not in the specific per-device front-ends. So I did that and added special DMA ops for the grant-based Virtio, which will replace the PFN, each PFN with a grant index. So the DMA op will just grant map or allow the backend domain to grant map the PFN and replace the PFN with the grant index in the ring page configuration, whatever. And I've added a high bit, so the highest address bit in this DMA address will be set to select grant mapping, because especially for HVM guests, I will still need normal guest PFN or guest physical memory access. So I need to be able to differentiate between grant accesses and normal memory accesses. In PV guests, there won't be any possibility to easily address physical addresses, so only grants, but the bit will stay there. And the grant capability, as I already said, can be selected via feature bit. I reuse this single feature bit, which is used to select special DMA ops for each device, which was introduced on 394. This is funny, for PV guest, which is protected virtual machine. So something similar to AMD SEV guests. Okay, so what is the current state of the prototype? Unfortunately, I wasn't able to finish it completely because I was distracted by several customer crises and had to work on that. But I have proof that my attempt will work, because I've seen that my front-end side patches for the Linux kernel, they are ready, and the ring page is filled appropriately and configured appropriately, and the grant flagged addresses basically are seen by the qemu side. I've done my tests with Virtio block. So I didn't do any configuration patches for that. I only added some additional command line options for the qemu device model in an HVM guest. I've chosen the HVM guests because adding a qemu-based PCI device for PV guests is work to do. The Linux kernel patches are really, really non-intrusive, basically. So I think I have less than 10 lines of code in the current Virtio framework. I just needed to add another driver, the Xen Virtio grunt driver, which contains the entry points and the new DMA operations. On qemu side, I have some patches ready and some are a little bit in working state. So first patch I did was for not unplugging Virtio PCI devices, especially block and network devices, when XenPD drivers are active, because the alternative would be to have only emulated devices in qemu. This is fairly easy to do, and I was planning to post this patch rather soon. I've added a special pseudo RAM region for Xen grants, and this is working well. I've added the framework for mapping grants via this pseudo RAM region, and this is in principle working. There are some problems because some of the mappings are done as they are needed, and some are needed very often. So I ended up in mapping the same grant page hundreds of times, which is not nice. So I need to have some caching around that. And this is what I'm just doing. Basically, everything seems to work. So when fine-tuned and the mapping, so the multiple maps being avoided, this should work. And I think if no other customer crisis is coming across, I will have a working prototype in, let's say, 2 weeks or so. What needs to be done in future? I'd like to have the same in the kernel on backend side, so supporting vhost. Vhost user is maybe a little bit different because this might spread to different daemons and so on. So this might be done on a case by case. One of the main issues waiting is the Xen tool support. This is for one, the config syntax, which needs to be decided on. And another major item will be the support for PV and PVH guests. So what do we do with the device model, basically, which is needed then for PV and PVH guests? So qemu-based PCI, the memory map, which needs to be presented to the guests, and so on. So this will need some further work. And another hack I did right now, I hard-coded the backend domain to be 0 for the grant mappings. So we need to decide how the backend domain ID is communicated to the front end. There are multiple possibilities for that. This could be PCI or MMIO-based config item, but this would need some extension on the Virtio side. But on the other hand, it could support something like driver domains in KVM as well. So Virtio spec might be changeable in this regard. Or we could think about using XenStore, for example, for that. But of course, yeah, this wouldn't be too hard, I think. but yeah, you would need to think about that. And of course, live migration support is something to think about. So the modified pages and so on should be done by the ground handling. This is basically architecturally done in Xen, but oh, great. Do you hear me?
Yeah, we can still hear you.
Yeah, okay. This was only the camera and so on, which is gone. Okay, interesting. I have no further slides, so nothing problematic in this regard. Okay, so live migration support needs to be a little bit thought about. And, okay. Here we go. And of course, I guess the performance will be initially not too good, but this can be tuned later and we can see how to make it more performant. Okay, that's basically all. Oh, quite nice in time. So I didn't have time to read all the questions we had. Let me redo that.
One
Jürgen, just kind of a meta question. Were you aware, Jürgen, that you're at least the fourth concurrent independent attempt to implement Virtio for Zen that's going on, as far as I know?
Okay.
Like, so the automotive guys are doing it, the OpenXT guys are doing it, some of the guys at Vates have looked at doing it, and so you're the fourth independent. So I don't know. Somehow in our community we need to figure out that, find a way to discover that we're doing these things, so we don't have four independent threads of trying to do this.
Yeah. So basically, I've seen some attempts. I stopped counting them, and I looked into it, and every time it was that there was no attempt to integrate grants, which was my idea since I think about 2 years or so. And I didn't have much time to look into it, and then when Xen Summit was coming up, I thought about something to present here and thought, well, let's put some pressure on me and just decide to do the talk and try to get something working, basically.
Okay, just to be clear, I wasn't criticizing.
Yeah. No.
I was just
absolutely fine.
I was saying,
so,
in our community, we need to make sure that we, Okay, so I think that's probably good, to have a forcing function to say I'm going to get a prototype and see how it works. So
yeah,
thank you.
Right. So this was the basic idea, to prove that my idea is able to work and still to really benefit Xen, so that it's not just a KVM replacement when using Virtio, but it still has some positive aspects compared to KVM. So the security in this regard. And that was the main motivation here.
On that subject, I do have one quick question. You said the ability to negotiate whether grants were used. Does that include the ability to state that a backend is only willing to use grants? Because that is also something I think we have use cases for.
Yeah, I have chosen to have a kconfig option on the front-end side, basically, in the Linux kernel, that you can configure the kernel to require grant support on the back end. And of course, this can be extended to be a boot time option or whatever.
Yeah.
So
I suppose
both ways are possible.
I think the other thing worth pointing out that has actually come up a lot in the comments, at least one of the other bits of work going on has been attempting to use Argo as a transport rather than grants. And the reason there is not necessarily is because we want more security than just blind DMA, but you don't want actually shared memory between two domains. So if it's possible to fit something like Argo into that model, which is a strict. So in Argo, you've got Zen doing the copy from one to the other. And I think that would also be very useful in some higher security use cases.
Should be doable, I think, because like at least on the qemu side, everything's done. It is possible to specify all the memory basically as MMIO memory, which is so IO memory handled between exchange between the two sides. So this should be doable, I think.
Fantastic.
To me, the main blocker of ground table on ARM is the fact the shared page is where we do the atomicity, and with LLLC atomics, it's a nightmare. So I can't see it adopted by any other project other than here.
Okay.
Have a look at the XSA we had a couple of years ago, but there is no forward progress guaranteed with the LLC, which is available until on all ARM v7 on ARM v8. ARM v8.1 introduced LSC atomics, which is better, but with the LLLC, then there is no way we can do something safe with ground table.
The other issue here is that RISC-V can't do an atomic operation on less than 32 bits, which means that you've got to fall back to a comp exchange and retry loop to do the 16-bit grant status updates. That is going to prove to be problems for the RISC-V port.
Okay. Yeah, but those are general problems then, right? Yeah, as I said, I think the basic principle should be possible for a copy type of synchronization or parameter exchange as well. But this would need some further work, of course, but at least where to look into, especially on the qemu side, my patches would be quite a good blueprint, I think. I think we need to stop, right?